Hey guys, good evening. I hope you all are doing good today. So, today we are starting our seventh part of our data engineering series. And you all know the routine: grab your coffee, come sit and chill. Make sure you're focused and you learn all these concepts so good that when you are asked with these kind of questions in your interview, you're able to answer well. So, I wish you good luck to learn all these, and keep learning again and again. It's not just about listening to the video once, but even after the video ends, if you have any question or any doubt, try to clarify either by yourself or feel free to drop your questions in the comment section, and I will address it whenever I have a look on those comment section. So if you find this video a beneficial one, do like the video as well, and click on the bell icon so that you don't miss on the regular updates. So before we jump to the video, who are we? We are Data Valley, the fastest growing edtech company of 2025. And we offer you with IT solutions, trainings, and placement support. So if you have any kind of query regarding, uh, multiple subjects, honestly, because in our academy, we teach multiple streams of subject, which includes data analytics, data science, data engineering, Selenium, Java, Python, C, C++, SQL, cybersecurity. So, to be honest, we have multiple domains in place. So, feel free to check our website so that you get a broad idea about our company, and feel free to ring to one of our team member, and they'll get back to you, and they can help you with your job and your placement. So, good luck with your learning and everything. So, today we are starting with our data engineering series part 7, and today I'm majorly covering questions in regards to Spark. So most of our questions are going to be in relation to Spark. All right. Okay, so let's start it. Okay, so we all would have heard the term Spark, right? Even in our previous data engineering series, we would have discussed about it. But do you know in a way that you can respond in an interview? So are you well enough or thorough enough to respond to an interview? But keep in mind that you're not just preparing for your interview. You might have your interview now or never, or you might be already in a job. It doesn't matter. But as a learner, okay, I wish you all to be a learner. So, as a learner, make sure that you understand the things, you understand the concept, you understand what is what, and how does these things work. In long term, these will help you to regain your knowledge. So, make sure that you learn it rather than memorize it, or just prepare for your quick interview and just go and appear for the interview. But in long run, these are going to be beneficial. So, make sure that you try to understand all the things that are being taught in this video. So, our first question: what is Apache Spark and why it is used? So, Apache Spark is an open source distributed processing system designed for large scale data analytics. It serves as a unified analytics engine with built in modules for various data processing tasks. So, three things I need you to keep in mind. Apache Spark is an open source system. So, what do I mean by open source system? So, Spark can be availed by anyone. Okay, it is not a proprietary software or a proprietary tool that can be used only by a specific company, or that can be accessed by only a specific people within a company, but rather Spark is an open source distributed processing system. Therefore, it doesn't matter what system you're using. So, for example, you might be using a different cloud. So, you might be based in Google Cloud. I might be based with the Azure Cloud. And someone else would be using an on premise legacy system. Even in that case, because Apache Spark is an open source system, I can easily just install the necessary software and the libraries, and then I can use the Spark as easy. So it's an open source. You don't need to purchase any license, or it's not proprietary to anyone. Second thing, it's a distributed processing system. What do I mean by distributed processing system? For example, let's say you run a Python code in your laptop. So can you say that if your system is distributed? No. The reason is because it is a standalone performance. And the Python code that you are running is just being run in your system, but it is not distributed. The processing is not distributed. So what do I mean by distributed? So while talking about the word distributed, your processing, okay, or your computing is split across different systems. So it is not just going to be run in a single system, rather you're going to have cluster of systems that are live, and by processing these data in a distributed fashion, you get to process your data very faster. So that's what I mean by it's a distributed processing system. And for what is the main reason for using this distributed processing system? The main reason is because you need to handle large scale data analytics. So by definition, you know what is a large scale, right? So you're going to have huge volume of data. For instance, if you try to load that in your laptop and if you try to run it, there are chances that your laptop will not be able to process it. Let's say when you have an high end processor, but there is certain limits for your processing. Maybe let's say your system still was able to process it, but the time spent on processing is going to be higher. But if I manage the workload in a distributed fashion, it's going to be very quick. So what is Apache Spark? Apache Spark is an open source distributed processing system designed for your big data analytics. And the next point is it serves as a unified analytics engine with built-in modules for various data processing tasks. So what do I mean by unified analytics engine? Talking about unified analytics engine, it provides us with a lot of functionality, hence making it highly valuable or one of the most important tool within a data engineering aspect. So the first thing that I would like to talk is batch processing. So talking about batch processing, it can handle large number of data sets in discrete batches. So what do I mean by batches? For example, let's consider our usual example. Let's say you run a shop, okay? You run a grocery shop. So you open your shop at 7 and you close your shop at 10. So all the transactions that has happened that day. So from morning 7 till the 10 in the night. So you're going to count all your cash once the shop is closed, and then you manage your finances, right? So you're processing it once, or you're counting your cash once in a day. Similarly, if you consider that in the data engineering aspect, same example, you have opened your shop at 7, you're closing your shop at 10. So in between, you're going to have a lot of transactions that happen in your database. So what could be a different transaction? For example, payment is a transaction. For example, someone ordered through an, let's say they are using Uber Eats. So they have ordered something through a third party vendor. So that is a transaction because the order is getting stored in your database. Or let's say someone is doing an in-store shopping and they made the purchase and they have paid for it. So the stock count is being, you know, uh, added to your database. So that is a transaction. So each thing that happens with the database is a transaction. So it is not just about payment transaction. It can be anything. So any information that is put inside your database, it becomes a transaction. So to handle all that, from morning 7 to 10, you wouldn't process the date, you wouldn't process all your data immediately, but rather you would wait till all the shop is closed. Maybe you can do your ETL job at midnight, let's say 12. So you're processing all your data as batches. So in this context, you're processing batch on an interval of 24 hours or on a interval of 1 day. So this is where your batch processing is. So you're processing all your data in a discrete batch order. Okay. Does it only support batch processing? No. Apache Spark also provides you with real-time analytics, or in other words, it also supports stream processing. So what do I mean by real-time analytics? So in batch processing, you're processing your data for every 24 hours, or you can have different timelets. For example, let's say you want to process all your data for every 6 hours. So that is one kind of batch processing. But in streaming or real-time analytics, as soon as a transaction occurs, you're going to process the data immediately and you're going to enable real-time insights. So that is where the real-time analytics come into play. Okay. Are these the only two functionalities? No. Spark also provides you with interactive queries. What do I mean by interactive queries? For example, you need to perform some ad hoc analysis on your data. Because Spark is very interactive, you can run your queries and you can check how your data manipulation has been done. You can immediately check what transformation has been done. So Spark also supports interactive queries, and it also supports machine learning. So machine learning is a very important concept, especially it's very booming with the era of AI. So Spark is enabled in a way that it can support machine learning as well. So to support machine learning processes, Spark provides you with a library called mlib. So the mlib library helps you with the machine learning algorithm. So you can develop, you can test, you can run all your machine learning models via help of mlib library within the Spark. And then it supports graph processing. So Apache Spark provides you with tools that helps you to work with your graph based data or graph structured data. So by combining all these kind of functionalities, Spark behaves like an unified analytics engine. So Spark is an open source, distributed, large scale analytic processing system. So that is what your Apache Spark means. Okay, we have seen what is an Apache Spark and we have seen how it is a unified platform. But do you know the key features and advantages of using Apache Spark? So let's see about it. The first thing we want to talk about the advantage is speed. So what is exceptional to Spark? So what makes a Spark a better tool? So what happens with the Spark is it utilizes in-memory caching and optimized query execution, significantly accelerating data processing compared to traditional disk-based systems like Hadoop MapReduce. So let's talk about this in-memory caching. So what happens with Spark is that it is an in-memory processing engine. So whenever a data is loaded, the data gets loaded to your memory, and once all the transformations and all the actions are performed on the data, only then it is passed on to the disk again. So it processes everything in memory. But if you consider traditional disk based system, what happens is, let's say you have your data in the Hadoop. So MapReduce needs to perform the processing. It fetches the data from Hadoop, it processes the data in memory, it writes back to the disk. And so as to process the next step or the next transformation, it again takes all your data from your disk, processes it in the memory, and then writes it again to your disk. So there is too much of movement between the disk and your memory. Therefore, there is going to be a lot of input and output happening, which in turn is going to significantly affect your performance. But rather, Spark uses in memory computing and also it supports caching as well. So, caching is like you store the uh, data temporarily in your memory. So Spark supports caching. So it's not necessary that you always have to load your data because Spark supports caching. It can just pick the data from itself or the cached one, and it can give you the result as quick as possible. And also it has optimized query execution. I don't want to explain that very detailed now, but for now just remember that whatever code you're providing to your Apache Spark, it first creates a logical plan, then it optimizes the logical plan. So whatever code you have provided, it performs an optimization by itself. And once the optimization has been done and the best plan has been chosen, it turns out to be a physical plan or the plan in action. Therefore, it provides you with the optimized query performance, because in the optimization process, your predicate pushdown or your early filtering or the choosing of a better joins, so these kind of functionalities run in your optimized logical plan. So hence making Spark a very faster executing system. Let's talk about flexibility. Spark can run on various environments. So what do I mean by various environments? So earlier I said you that Spark is an open source system. So because it is open source, Spark can be run in different systems or in different cloud-based systems or different traditional based system or different legacy based system. So if you see Spark, it can run on top of Apache Hadoop. Is that the only option? No. If I want to run it in a container, yes, I can run it within the Kubernetes. Is that the only option? No. I can run in a standalone cluster. So what is a standalone cluster? Let's say you can install Apache Spark in your laptop and you can still work on Apache Spark, so which is a standalone cluster. Is that the only limit? No. You still can run it in cloud platforms. Even talking about cloud platform, because it is not proprietary, it can run with different clouds. Let's say you're using GCP, I'm using Amazon. No worries, Apache Spark can still run on those systems. So that is the flexibility Apache Spark provides you with. It provides you with multi-language support. So talking about multi-language support, we have too much of programming languages in place. And the most common would be Java, Python, maybe R, and certain people also use Scala nowadays. It doesn't matter which programming language you use. Spark provides you with APIs that supports variety of languages, therefore making all the developers feel easier to work with Spark. Because let's say I know only Python. In that case, I can just use Python API to work with the Spark technology. Therefore, I can still obtain my distributed processing. So it provides you with multi-language support. And then I said you earlier, it provides you with unified platform. So talking about unified platform, it integrates with different data processing paradigms into a single platform. So earlier we saw about batch processing, real-time processing, machine learning, working with your graph data. So all these kind of data processing paradigms are just put into a single platform, therefore simplifying complex data workflows. Also, Apache Spark is fault tolerant. What do you mean by fault tolerant? So Apache Spark is very resilient, and therefore even if there is any breakage or if there is any damage or if there is any uh, let's say an interruption to your data lineage, it doesn't matter. Apache Spark helps you with fault tolerance capability. Therefore, what happens is Spark has something called as resilient distributed data sets. Okay, even if you're working with the data frame by under the hood, it's all odds that is working in place. And the specialty about RDDs are they are immutable. So all your processed data that are put as RDD are immutable, and you can track the lineage so easily. So what do I mean by tracking the lineage? Let's say initially you had an original RDD, and then you performed a map reduce on top of it, and then you performed a flat function. So for each function you'll be creating a new RDD. No matter what, let's say at the fourth stage of creating new RDD, there has been some interruption and my code didn't execute or it failed. It's okay, because Spark provides you with fault tolerant capabilities. You can track the lineage, or you can track the originality or the root of your data, and then you can reconstruct all your data loss if there was any chance of data loss. So these are the key features of Apache Spark. And this is the most important question for any data engineering interview. Explain the architecture and the components of Spark. So you might be even a seasoned pro, doesn't matter, because everyone has to understand the architecture and the component of Spark. So I ask everyone to pay attention towards this concept. Talking about the architecture of Spark, Spark provides you with master worker architecture. Earlier it was called as master slave architecture, but considering this modern era, they have changed it to master worker, because master slave, I mean, it is not an appropriate term in the social justice, right? Because they don't want to have anything called as slave. So considering the social norms, they have changed it to master worker architecture. So it employs with the master worker architecture for distributed computing, designed to handle large scale data processing efficiently. So this is the working capability of Apache Spark. So it needs to provide you with large scale data processing, and therefore it also distributes all your processing and computing to process your data. Okay. So on what basis does it work? It works on the basis of master worker architecture. And I all ask you, please pay attention to all the key components that I'm explaining now, because if you understand the key components, next you will be able to understand the diagram that I have shown in here. Okay, this is from the official Spark documentation. So talking about the key components, you have a driver program, you have a master program, sorry, you have a worker node, and you have an executor. So these are the four core components of your Spark: driver, cluster manager, worker, and within the worker node, you have an executor. Do not worry about cache tasks. We will talk about them later, but these are the crucial components of your Spark architecture. Okay, let's talk about all these components in detail so that we understand what these components can do and how do they interact and get all our data processing properly done. Okay. The first thing that I want to talk is Spark driver. You can consider that Spark driver is like the CPU for your computer. In case if you're not using old kind of computer, you can just imagine that these are the RAM of your system. Okay, so these are the processors of your mobile. These Spark drivers act like a brain for all your Spark application. So what it does is it runs the main method of the user's program. So what do I mean by main method? When I submit a Spark code, okay, let's say I've wrote some Spark code and I submit it. When I submit the Spark code, the main method is how I access the code. So using this main method, I can access the code. And what this Spark driver does is it is able to run the main method of your user's program. So whatever code I have written in my Spark application, It can access via main method, and it also runs the methods within the main method. As a Spark driver, it is responsible for certain things. First, it creates a Spark context, or in earlier or in newer versions, it is called Spark session, which provides you with multiple entry point. We'll talk about it later, okay? But for now, I want you to know that it creates something called a Spark context. So if you ask what is a Spark context, these are the entry point for your application, okay? So it creates Spark context, or in newer versions, it is Spark session, and therefore after creating, it also helps you with the coordination of your task. So all your tasks that needs to be performed, Spark driver is the one that coordinates and executes them. And then we earlier talked about different language support provided with Spark, right? So whatever code I've written in different languages, driver translates my code into a logical plan. So logical plan is how my code is going to be executed. So what is the filter I'm performing? What is the join I'm planning to do? So these kind of plans will be selected by your driver program, by which the optimization happens as well. Driver also divides the job into tasks and schedules them for execution on the cluster. So whatever the job that I've provided to my Spark driver, it divides it equally into different tasks, and then these tasks are scheduled for the executor to be performed in their own cluster. Spark also maintains the metadata about the job, such as state of ODDs, data frames, and task progress. So what do I mean by metadata about the job, and what do I mean by state of ODDs? Earlier I said you that one of the advantage of using Spark is fault tolerance. So what happens in your fault tolerance? You will be able to track your data lineage. So what happens is Spark driver is the one that has the metadata about all these RDD and data frames. Okay, so therefore helping us with fault tolerance as well. Spark driver is also important for interacting with all our cluster manager, and it schedules the task on our worker nodes. So driver, whenever you submit the code, it reads the main function, right? Main method. So once it reads the main method, then it speaks with the cluster manager. So you see here, right? So driver program interacts with your cluster manager, and it is responsible for scheduling the task on the worker nodes. So that is the main purpose of driver component. Okay, let's talk about the cluster manager now. So cluster manager is the next one to the Spark driver program. So cluster manager allocates resources across the cluster for Spark application. It acts as an intermediary between the driver and workers. So you have your workers here, you have your driver here, and in between, like a broker, cluster manager comes into play. So what does this cluster manager do? The cluster manager allocates resources. Resources include your CPU and memory across the cluster for the Spark application. So what are the different supported cluster managers do we have? So we have standalone architecture. So standalone is Spark's built-in cluster manager. Okay. So for example, if you're running a Spark application in your laptop or a PC, you're going to have the built-in cluster manager provided by Spark itself. So that is a standalone cluster manager. And then you have Yarn. Yarn is yet another resource negotiator. Okay. So what this does is this negotiates the resources across the cluster. So Yarn is specifically uh, compatible with your Hadoop. So this is, in another term, it's a Hadoop's resource manager. Then you have Mesos. So Mesos provides you with a general purpose cluster manager. Then you have Kubernetes. So Kubernetes provides you with containerized environments. So these are different cluster managers supported across your Spark application. Cluster manager assigns executors to the application and monitors resource usage. So whatever the driver application has been initiated, it communicates with the cluster manager, and the cluster manager provisions all the resources and asks the worker node to perform certain logical or your DAX or your plans. And then let's talk about the worker node. Worker node or the slave nodes, but nowadays we don't mention it slave nodes. But just for nodes purpose, I want you to know that earlier it was called a slave node. So worker nodes come under your driver, and worker nodes are the machines in the cluster that host one or more executor. So what do I mean by one or more executor? For example, if you see here, I've got a worker node, and then within a worker node, I've got an executor. Just because there is one, it doesn't mean that it provides you with just one executor. Rather, you can have multiple count of or multiple clusters of executor within a worker node. So worker node can initiate or run multiple executes within its node. They receive tasks from the Spark driver via the cluster manager and executes them. So cluster manager communicates from the Spark driver to the worker node, and then it initiates the application and it executes them. Each worker runs a Spark daemon, or you can call it as worker process that communicates with the cluster manager and driver. So all the worker node is going to have a Spark daemon which can communicate with your driver program. And then the final thing is about executor. So where does these executors come? Executors are within the worker node. So executors are JVM processes. What do I mean by JVM processes? JVM refers to Java Virtual Machine. So executors are Java virtual machines running on worker node. So as I've said earlier, here you have got your worker node, and within the worker node you have got your executor. So executor by itself is a JVM processor, and it is responsible for executing all the tasks assigned by the driver. So whatever the task that needs to be performed, it is done in your executor. And also these executors can store your data. So for example, let's say you need to cache your data frame, let's say you need to persist your data frame. So in that place, executor is the one that does all the storing of your data, and it can store the data either in the memory or in the disk. So it depends on the location that I said, but it provides you with flexibility as well. And then executors are also responsible for reporting task status and results back to the driver. What do I mean by task status? Let's say driver has assigned certain tasks to your executor, but your executor has failed to perform it or it has successfully performed it. In case of success, what happens? Your driver is going to give next task for the particular executor to run. In case if it is failed, it is going to communicate to your driver saying that okay, this has been failed, so can we do something about it? If you have retry mechanism in place, yes, retries are possible. But let's say in simple words, all your task status are reported back to your driver. Each executor runs its own JVM and can handle multiple tasks concurrently. So each executor run their own Java virtual machine, and they can also handle multiple tasks concurrently. So as you see here, within a worker node, I've got executor, and each executor can have multiple tasks running in them. So just for now, remember that tasks are partitions. Okay. So within these partitions, a data processing will happen. So that's what I mean by tasks. They also manage cache data and communicate with your driver program. So executors are the one that has your cache data, right? So they are responsible for all your caching, and they also can communicate with the driver program directly. So that is all the key components of uh, Spark. So now we will see how does this architecture all work together to process a particular Spark application. So make sure that you remember this architecture, okay? And now my next question leads up to, how do the components work together? What do I mean by components working together? In other words, what I am asking is, when you submit a Spark application or a Spark job, how does all the components within these your Spark come together to perform that particular execution? Okay, here is a simple analogy I've gotten here, but we will see very detailed about what's happening in and out for each of these components. But for now, I just want you to remember this 10 steps, which will be most frequently asked in your interview as well. First, what do we do? The user submits a job using Spark Submit. So whatever the Spark application that you have developed, you use a Spark Submit command to submit your Spark application to your Spark system. So once you have submitted your job, Spark Submit will turn will turn in and launch your driver. So driver is the brain or the CPU of your Spark application, right? So whenever you perform a Spark Submit, it will launch your driver program, and then it will execute the main method of our code. So our code or application is going to have a main method. So once the Spark is submitted, it it launches the driver, and the driver will execute the main method. Then Spark contacts the cluster manager and requests for resources to launch the executor. So once the driver program has been initiated, the driver communicates with your cluster manager and requests for resources to launch the executor. So what are you doing? You have a user. User is submitting a Spark job via Spark Submit. And once the Spark Submit has been initiated, driver program is initially created. And this driver program will communicate with your cluster manager. And now this cluster manager provides you with resources, so which in turn will launch your worker nodes as well. The cluster manager launches the executors on behalf of the driver. Once the executors are launched, they establish a direct connection with the driver. So Spark driver is initiating the cluster manager to provide you with resources. So because of that, you get your worker nodes and executor. And now your executors will be able to directly communicate with your driver program. The driver determines the total number of tasks by checking the lineage. So driver, they'll check what is the total number of tasks that we need to perform. So how does it come to that conclusion? It checks for your lineage. How does it check for your lineage? So you're going to have your DAG developed for your Spark application. So these DAGs are accessed by your driver to develop or determine what is the total number of tasks that we have, and it comes to a conclusion of the total number. And once the number of tasks have been confirmed, the driver creates a logical and physical plan. So what happens now, as I said earlier, you have your logical plan. So logical plan is whatever the code that you have submitted, and internally there is something called as catalyst optimizer. It kicks in to optimize your code. So this is the one that converts your logical code into an optimized logical code. And then after the optimized logical code, it is then converted into an physical plan. So the driver creates a physical plan, and once the physical plan is generated, Spark allocates the tasks to your executor. So from the plan, what happens is Spark will allocate the number. So you already have determined what is the total number of tasks, right? So you already know what is the number of tasks that you have. And now what happens is the Spark allocates these tasks to your executor. So each executor is going to have multiple tasks to be performed, which are assigned from your driver. And then tasks run on executor, and each task upon completion returns the result to the driver. So all your tasks that has been running in an executor, because you have a Spark daemon, it communicates with your driver, isn't it? If your task is completed or what is the status of it, it gets communicated. So upon each completion, these results are returned to your driver. Finally, when all the task is completed, the main method running in the driver exits. That is, main method invokes Spark context dot stop. So Spark context is your entry point to your application, right? So it initializes Spark context dot stop method. So what's happening when all the task is completed? The main method running in the driver exits. And now, because the main method has been stopped, and your Spark context has been stopped, now what happens is Spark will release all the resources from your cluster manager, because the Spark application or Spark performance has been done, right? So whatever is expected is done already, and now they are all closed. So the resources are released. Okay, now let's just revise it. You submit a Spark job via Spark submit command, and once you submit your Spark submit, the driver program launches a Spark context. Okay, so your driver program gets launched and it reads for your main methods, and depending on that, it also initializes your cluster manager, and the cluster manager will initialize the necessary resources include CPU and memory. So it launches all your resources, worker node, and for each worker node you get your executors as well. And once the executors are launched as well, the executor communicates directly to your driver program. So whatever code that you have submitted, the logical plan is made into a physical plan, and Spark would already determine the number of tasks that you need to perform the particular physical plan. So now what happens is this physical plan will start getting executed. How? The Spark program will ask the executor to perform all the tasks that has been provided. So upon completion, executors communicate directly with your driver saying that if the task is completed and what is the status of it. And upon each completion, new task gets assigned. And let's say all your task has been completed, which means that your Spark application or your Spark job has been successfully performed. Now the initialized Spark context gets stopped. And now once when it gets stopped, it asks the cluster manager to release all the resources. That's simple, right? So this is the architecture, components, and how all these components would come together to perform your Spark job together. So I hope this session was very beneficial to you. We we quite learned a lot about the Spark, isn't it? So it is good to learn about one concept today. And the reason I didn't choose multiple concepts today is because Spark is very important for any data engineering interview. So I thought maybe, instead of confusing you all, I should have all of them together, so that it benefits you in a better way. So if you like the content, do drop a like. If you have any questions, drop your questions in the comment section. I will surely address it either in this session or in the forthcoming sessions. Few people asked about the resource material. I will provide it soon. I'll provide you with a GitHub link so you can access it directly from my GitHub as well. Feel free to connect with me in the LinkedIn. Myself, Franklin Florence. I failed to introduce myself at the beginning, so I'm Franklin Florence. I have almost 3+ years of experience as a data engineer. So do check out my LinkedIn profile. Okay, it's Franklin Florence, Franklin with the E. And before we end the video, I just want you to know that we are Data Valley. We are the fastest growing edtech company of 2025. And also we have our headquarters in multiple locations. So our headquarters are from US, and then we have UK as well. And we have our centers in UAE, and we have established four data centers in Hyderabad as well. And soon we are expanding to Chennai, Bangalore, West Bengal, Delhi. So we have quite a big plan because there are a lot of people coming for our IT solutions. People are coming for training. People are coming for placements. And if you are stuck at any point of your career, feel free to check our website and ask one of your colleagues. And our colleague will be happy to help you with your job and your career development. So thank you so much for tuning in. We'll catch up with you in the next session or maybe Monday. So until then, revise all these lessons. Make sure you're thorough about all of these. So thank you. Bye bye. Take care. I hope you all have a nice day. Bye bye. Take care.